All right. So it is create model relationship. Now, together with the model tables, model relationship form the basis of a tabular model. Relationships are responsible for the propagation of filters to other model table, and when correctly set up, they silently work to provide a natural, intuitive query experience. Okay, so this is so in this section we'll see that how can we create model relationships. So let's get started. Understand model relationship. So a model relationship propagates filters applied on the column of one model table to a different model table. Filter will propagate so long as there's relationship path to follow, and which can involve propagation to the multiple tables. Now relationship paths are basically deterministic, meaning that filters are always propagated in same way and without random variations. Relationship can, however, be disabled or have filter context modified by the model calculations that use particular DEX functions. So, in this example, the model consists of four tables: category, product, year, and sales. The category table it refers to the product table, relates to the product table, and product table relates to the sales table. Here year table also relates to the sales table. So a query possibly generated by Power BI card visual, it requests the total sales quantity for sales order made for a single category, okay, which is category A, and for a single year, CY 2018. Okay, so it's why you can see the filters applied on the category and year table, and the filter on the category table propagates to the product table to isolate two products that are assigned to category A. Okay, and the product table then product table filters propagate to the sales table to isolate just two sales rows for these products. Okay, so these two sales rows represent the sales of product assigned to category A. All right, so their combined quantity is 14 units. All right, and at the same time the year table filter propagate to further filter the sales table, and resulting in just one sales row that is for product assigned to category cat A, and that was ordered in year CY 2018, and the quantity value returned by the query is 11 units. So this is what is described in this small video, which is uh, playing on the slide right now. Okay. So it is identifying what is the sales quantity of cat A in CY 2018, and the final answer is 11. Okay. So now let's move on. Okay, apply star schema design principles. So we recommend you apply star schema design principle to produce a model comprising dimension and fact table. It is common to set up a Power BI to enforce rules that filter dimension tables, allowing model relationship to effectively or efficiently propagate those filters to the fact tables. So this image here is the model diagram of adventure work sales analysis data model. It shows a star schema design comprising a single fact table named sales, and other four tables are dimension tables that support the analysis of sales measure by date, state, region, and product. Here we can notice that the model relationship connecting all the tables, okay, and these relationship propagate filters that are directly or indirectly to the sales table. Now sometimes we also use disconnected tables, though it's unusual that a model table is not related to another model table, and such a table in a valid model design is described as disconnected table. So a disconnected table is not intended to propagate filters to the other data, model tables. Instead, it accepts user input, perhaps with a slicer visual, and allowing model calculation to use the input value in a meaningful way. For example, consider a disconnected table that is loaded with a range of currency exchange rate values. So as long as filter is applied to the to filter by a single rate value, a measure expression can use that value to convert sales values. All right. Now let's move on to our next slide. Set up relationships. So a model relationship, it relate one column in a table to one column in different table, and each model is defined by a cardinality type. So there are four cardinality type options representing the data characteristic of the from and to related columns. The one side means the column contain unique values. The many side means the column can contain duplicate values. Okay. So the four options together with their shorthand notation are described here. Okay. So first is one to many. So it we represented by one and star. Then we have a many to one. So we write it as star uh, uh, and ones. Then one to one. So it is like one colon one, and then we have many to many. So for that we just put the colon. Okay. Now in Power BI desktop model view, we can interpret a relationship's cardinality type by looking at the indicator whether it's a 1 or star, or we can also call it as wildcard character on either side of the relationship line, as it's visible on in the figure as well. So to determine which columns are related, you will need to select or hover the cursor over the relationship line to highlight the related columns. So the one to many and many to one cardinality option are the same, and they are also the most common cardinality types. Now, when configuring a one to many or many to one relationship, we will choose the one that matches the order in which you relate the columns. Now, consider how you would configure the relationship from the product table to the sales table by using the product ID column found in each of the tables, right? So the cardinality type would be one to many, as the product ID column in the product table contain the unique values, And if you relate the table in the reverse direction, that is sales to product, then the cardinality would be many to one. All right. So each model relationship is defined with the cross filter options or cross filter direction, and your setting determine the direction that filter will propagate. So the possible cross filter option are dependent on the cardinality type. So single cross filter direction means a single direction, and both means both direction. A relationship that filters in both the direction is commonly described as bidirectional. So for one to many relationship, the cross filter direction is always from the one side and optionally from the many side. For one to one relationship, the cross filter direction is always the both always from both the tables. And lastly, for many to many relationship, cross filter direction can be from either one of the table or from both the tables. So this is also represented in the table which is shown on the presentation. Okay, you can have a look on it. Now let's move on to our next slide, which is using DEX relationship functions. So there are several DEX functions that are relevant to model relationship. So first one is related. Okay, this related function, it retrieves the value from one side of a relationship, and it is useful when involving calculations from different tables that are evaluated in row context. Then we have a related table. So this function, it retrieves the table of rows from the many side of the relationship. Another DAX we have is user relationship. So this function forces the use of a specific inactive model relationship. It's useful when your model includes a role-playing dimension table and you choose to create inactive relationships from this table. Then we have cross filter. So this function either modifies the relationship cross filter direction to one or both, or it disables filter propagation none. It's useful when you need to change or ignore model relationships during the evaluation of a specific calculation. Another dx function that we have is combine values. So this function join two or more text strings into one text string, and the purpose of this function is to support multi-column relationships in direct query models when tables belong to the same source group. Okay. Then we have treat as function. So this treat as function applies the result of a table expression as filter to the column from an unrelated table. It's helpful in advanced scenarios when you want to create a virtual relationship during the evaluation of a specific calculation. Another one that we have is parent and child function. So these kind of function are family of related function that you can use to generate calculated column to naturalize a parent-child hierarchy. You can then use these columns to create a fixed level hierarchy. All right. Now let's move on to our next slide, and let us try to understand relationship evaluation. So, model relationship from an evaluation perspective are classified as either regular or limited. and it's not a configurable relationship property. It's inferred from the cardinality type and the data source of two related tables. So it's important to understand the evaluation type because there may be performance implications or consequences should data integrity be compromised. Okay. So there are certain relationship evaluations. Like first one is regular relationship. So a model relationship is regular when the query engine can determine the one side of relationship. It has confirmation that the one side column contain unique values. All one-to-many intra-source group relationships are regular relationships. After that, we have limited relationship. So a model relationship is limited when there is no guaranteed one side. And a limited relationship can happen for two reasons. First one is that relationship use a many-to-many cardinality type, even if one or both column contain unique values. And second one is that relationship is cross source group, which can only ever be the case for composite models. Then after that we have a precedence performance preference, and before that we have precedence rules. So bidirectional relationship can introduce multiple and therefore ambiguous filter propagation path between model tables. Okay, and the list that present precedence rules that Power BI uses for ambiguity detection and path resolution is many to one and one to one relationship, including limited relationships, or it could be many to many relationship, or it could be bi-directional relationship in the reverse direction. And the last one that we have is performance preference. So here in the performance preference, uh, some cases like one to many intra source group relationship, many to many model relationship achieved with an intermediary table, and that involve at least one bidirectional relationship, and then many to many cardinality relationship. So these order filter propagation performance from fastest to slowest performance. Okay. So this was it with our second section, all right, which was about creating model relationship. Okay, so now let's have a look at the demo of work with model relationship. All right, so here we will work with the model relationship specifically to address the need for role playing dimensions, and we will interpret relationship properties in the model diagram, and we will also set the relationship properties, and we'll learn how to use des function that modify relationship behavior. All right, so let's get started. So here I have already downloaded a sales analyzer starter file. So let me just open that file in the Power BI. All right, so we can see at the right hand side the data pane in which we can see all the tables that are there, and we can also open the model view. Okay, and we can review the model design. So this model comprises of six dimension tables and one fact table, which is the sales fact table, and this table store the sales order details. So basically, if I minimize and show you, it is a classic star schema. Now, we notice that there are three relationships between the date and the sales table. Right? If you see date and sales table, there are three relationships between these two. And if I hover my mouse over these lines, so I can see what all columns are in the date table is connected with the columns in the sales table. So if we see the date key column is connected with order date key, it is also connected with the due date key, and it is also connected with the ship date key. So basically, a date key column in date table is unique column, and it represents the one side of the relationship. All right. Now, if we notice that order date line, this line of relationship is solid line, while other relationships are represented by dotted lines. So a solid line represents an active relationship, and there can only be one active relationship path between two models, and the path is used by default to propagate filters between the tables. And if we talk about dotted lines, so it represents an inactive relationship, and it is used only when any explicitly invoked by DAX formulas. So here, this current model design is indicating that date table is the role-playing dimension, and this dimension could play the role of order date, due date, or ship date, and which role depends on the analytical requirements of the report. Okay, so in this lab, in this demo, we will learn that how to design a model to support role-playing dimensions. So let's first visualize the data. Okay. So we'll switch on to the report view, and from the visualization pane, we will select the table visual icon. Now to add columns to this table visual, so in the data pane, we will expand the date table, and from the date table, we will take the fiscal year column and will drag it on the table visual. Okay. Now, so we can see that fiscal year column has been added. Now we'll expand the sales table, and then we will drag the sales amount column into the table visual. Okay, let me just maximize it. All right, so now we can review this table visuals that it shows the sum of the sales amount column grouped by the year. But here, this fiscal year, what does this mean? Because there is an active relationship between date and sales table to the order date key column. So this fiscal year here means the fiscal year in which the orders were made. So to clarify which fiscal year, it's a good idea to rename it. Okay. And for renaming it, we will go to the values pane. Inside the visual pane, we'll go into the values. Okay, so here in the columns, I have fiscal year, and I will rename this visual. So here I will put the name as order year. All right, now we can see that the name is also changed in the column. Okay. So this is the way we can change the name of collar header as well. Okay, now we will modify the active relationship status. So for that, on the modeling ribbon, we will select Manage Relationships, and in Manage Relationships window, here for the relationship between the sales and date table for order date key column. So we will uncheck the active checkbox. All right. So here we will uncheck the order date key, and then we will check the active checkbox for relationship between sales and date table for ship date key. So we will do that. So now what is happening by this checking and unchecking, that the active relationship between date and sales table is switched to the ship date key rather than order date key. Okay, so now I'll click on close, and now we will rename this order year as ship year. Okay, it's done. So here the first row, it represent a blank group because some orders have not yet been shipped. And in other words, we can say that there are blanks in the ship date key column of the sales table. Now in manage relationship window, we'll again click on manage relationship window, and now again we will switch the or revert the order date key relationship back to the active relationship. So for that, first we have to uncheck the active relationship which is there with the ship date key, and we will check the order date key. Okay, now close. Again, we will rename. We can see the changes in the table visual, and again we will click on this arrow, order year. Okay, so this is how you can change the active relationship. You can modify the relationship active status. Now, how to use inactive relationship? So for that, we will be using user relationship function to make an inactive relationship as active. So for that, in the data pane, we will right click on sales table and we'll click on new measure. Okay, I will expand it. And now here I will just put some formula. All right, and I will change here. I want to change this decimal to, and then I will press enter. So this formula basically it is using the calculate function to modify the filter context. It is using user relationship function that makes the ship date key relationship active. Now in the sales, we can see that the sales shipped measure has been added. A column named as sales shipped has been added in the sales table. Now I'll just minimize it. Okay, so now I will drag this sales shipped in the table visual. Okay, so this creating this measure, uh, it is setting temporarily the relationship as active, and it is one way to do this. All right. So now to remove the measures from the table visual, what can we do? From the columns, we can just click on the arrow of the sales shift, and I will select the close option or X button. All right. Now to add another date table, what we will do, we will uh, here we will add a date table to support ship date analysis. So first we will remove the inactive relationship, and for that we will go to the model view, and in model view what we will do, uh, the relationship which is there with the ship date key, we will just right click it, and I will click on delete. So it is confirming. Click on yes. So we can see that how to delete a inactive relationship. Now we will use the disable relationship option. Okay, and for that what we can do is we will go on file, and we will click on options and settings. Options. Now in the current file, we'll click on data load, and we will uncheck all these two check boxes, which is about import relationship from data source on first load, and auto detect new relationship after data is loaded. So we'll uncheck all these two, and then we'll click OK. All right. So now we will add another date table. And how can we do it? So for that, we will go on the home ribbon, and in the home ribbon, we have transform data tab icon. So we will click on transform icon, and this will basically, it will open a new Power Query editor. All right. So here, if I click on custom, okay, that's great. So here I will go on data, and in the here, what will I do? I will right click and click on reference. So basically a reference query, a referencing query is one that uses another query as its source. So this new query source is sources its data from the date query. All right. So in the query setting properties, I will name this query as ship data, ship date. Okay. And I will also replace the text of the uh, date key as ship date key. So how can I do? I'll just double click it, and I will put here ship. All right. We will also rename the fiscal year as ship year. Okay. So although it's a good option or good idea to rename all the columns so that they describe the role they are playing. Okay, but here we will only be renaming two columns. Okay, now to load the table to the model, we will click on the close and apply icon on the home ribbon tab. So we'll click on close and apply. Now create a relationship from the ship date table and drag ship date key to the ship date key of column of sales table. Okay, so now we can see that an active relationship now exists between ship date table and sales table. Now we will visualize the ship date data. So for that, we will switch to report view, and we will just click on the copy and paste. So with this, we can just clone our table visual. All right. So now we'll select the new table visual, and here we will remove the order year, and we will just add here a new field to this new table visual. So from the ship date table, we will drag the ship year inside the columns. Okay, just move it up and down. All right. So now this model has now two date tables, and each with an active relationship to the sales table. So the benefit of this design approach is that it is flexible, and it's now possible to use all measures and summarizable fields with either date table. Okay. So now we'll explore other relationship functions, and we will be working with other DEX relationship function. So for that, let's first select the sales ship measure in the sales table. Okay. And now in the formula bar, we will replace the text with the some other code. Okay. Okay, so now we have replaced. Okay, so this formula, it is using calculate function to sum the sales amount column by using modified relationship behavior, and the cross filter function disable the active relationships to the order date key column. Okay, and this treat as function, it creates a virtual relationship by applying the in text date key value to the ship date key. Now we will add the revised sales shipped measure to the first uh, table visual. All right, so we'll just select the first table measure, drag it here. All right. Now we can notice that there is no blank group. Because there are no blanks in the order date key column, a blank group was not generated. So it's showing that unshipped sales will require a different approach. Now to show the unshipped sales, what we will do, we will create a measure named sales unshipped in the sales table. So again, in the sales table, we'll create a new measure. Okay, so for that, let me just paste the formula. Okay, so we can notice that a new sales unshipped measure has been created. Okay, now we'll format it to 2 decimal places. And now we will select the card visual from our and we will just drag the sales unshipped card here measure here. So this verifies the final report page. So let me just minimize it a bit. And this is the final look of our report.